Okay, good afternoon. I'm going to assume that most of you are Java developers. Who is a Java developer? Who has heard of Java? Who's been on Java? Who drank some Java? Okay, at least we know I've said the word at least 3 times. But before we start, I need to start with a little story. Space, the final frontier. That was pretty much the tagline of one of my favorite shows in my childhood. Star Trek, The Next Generation. Who of you have seen that series? Okay, who of you is more of a Star Wars fan instead of a Star Trek fan? Who is more of like, I don't care if it shoots in space, it's all cool? I'm with you, folks. I do not care if it's Star Wars versus Star Trek versus whatever. Hey, it shoots in space, it's pretty cool. But you know what? The fun thing about Star Trek is, and was basically, that if you look at the technology, it actually could be true, or maybe it is already true. Like, they have a vision inside in towards the future that these things might happen. However, if you look nowadays at things like their computers back in the original series, and I show this machine to my little cousin, he will be like, dude, whatever. My smartphone has more computation power than that box with light bulbs on it. So, in many cases, the series, although it's in the future, it actually, the reality took way faster and got ahead of the actual series. Fun fact, if you look at the sliding doors in Star Trek, at that point in the original series, they didn't have any sensors. So there were people behind the scenes opening and closing the doors. And if there are 2 doors, they go asymmetrically, asynchronously, which is actually quite fun. Just take a look at that. However, there is one particular thing that I personally hope that we will have in the future. Something like this, the thing of transportation. Making sure that I am standing here, and if I need to go home, I not need to go to the airport, go in line, make sure that I go through security. No, it's just like, here, decompose my body into a stream of bytes, send it over the air back to my home country, and compose myself back into the object that I am. Well, wait, haven't we heard that before? That is basically what we're doing with serialization and deserialization in Java. We have an object, we try to compose it into something, and send it away. That's what we're going to talk about. Oh, this is me. I'm a staff developer advocate working for Sneak. If you ask 10 developer advocates what developer advocacy is, you will get 25 different answers. So in my case, I used to program a lot, and now I email and do these kind of presentations. Now, I am, they told me I'm a Java champion. I still don't know why. I lead the virtual Java user group and the Netherlands Java user group. I am based in a small city an hour south of Amsterdam, and a bit more, which is not really important because we need to dive into what we call the gift that keeps on giving. That sounds pretty much like Christmas to a lot of folks, but it's not. Trust me. It's giving in the wrong direction. So, who knows? I had this poll out on the Wova app. I'm not even sure how you pronounce that. But I had the question like, do you know how serialization and Java serialization and deserialization works? Some folks said, yes, I do. But I want a show of hands. Who knows exactly how serialization and deserialization works? That's exactly 0 people. Who thinks they know kind of how it works a little bit? All right, we're there. Who uses serialization and deserialization in their day-to-day applications? And then I'm referring to specifically Java's custom serialization. All right, if you're not, then you think, I don't care, maybe your libraries do. So bear with me, because I will give you the TLDR version of how serialization and deserialization works. First of all, you have an object. By serializing it, you transform that object into a byte stream. That byte stream, you send it over the network towards either another computer on your network or over the internet to some other machine. Guess what? Deserialization is the other way around. So we have that thing on, for instance, on file on a disk, or from the other side of the internet. We have that byte stream coming in, and we compose it back to the original state of a object. Well, that was my TED Talk. Thanks for attending. No, I'm kidding, because we need to go into the deep dive because it's the gift that keeps on giving. Well, say we want to serialize an object, and I created a very small value object for you. This has nothing to do with Project Loom and value objects in general. I called it a value object because it had a value. And yes, naming is hard. You'll see. Anyway, this object has two fields, a value and a side effect, for obvious reasons. Because how do I create such an object? By using a constructor. And the constructor in this place has the string value as a parameter. It sets the value, and the side effect is set as a side effect in the constructor. If we want to serialize and deserialize this object, we just implement serializable. Done. And that was the intention of creating the whole deserialization and serialization libraries in the Java API. Make it simple. Well, they succeeded to make it simple, but also to make it a mess. Okay, so again, we have the constructor, and this is how you normally create a value. If I create a value now, the side effect would be the local timestamp of this moment. All right, so see, if I want to serialize that, and for reference, I put that object again here, I just have to do a few things. And for this example, I'm serializing to a byte or to a byte stream and then store it into a file. So it would be something like this. It's not the most prettiest code, so I hope the Sonar folks are not watching. Yes, you should do try byte with resources, I understand, but just for the sake of argument. File output stream, object output stream, and I write the object into the output stream, I close it and done, right? Nothing special. But guess what? Let's look into that file that I just created. And if I look into this with a hex editor, it looks something like this. I can pretty much read whatever is in that file. I can read what the package name is, where the fields are, and what the values of that field are. The thing is, because there's no such thing as checking that object, I can slightly change it into something else. I can go in there and change the value of a certain object. That is already a big thing, because it means that the integrity of your data is not something that is there persistently. It can be something different. You're not sure. Well, let's look into deserialization. And now my laptop is off. Bear with me for 1 second. Now let me see if I can put that other thing on. What was it again? Live demos, I love them. I have this program, I think it's called amphetamine, yes, because I'm from the Netherlands. Indefinitely, so it stays on. So we don't have the problem again. So say, let's look at deserialization. So for reference, I again have this object, that same object that I want to deserialize that stream back in. Let's look how you do that. It's basically three lines from that file back into the object. File input stream, object input stream, and then the third line. It's set in.read object, and then I cast it to a value object. Okay, so first of all, I am not using the constructor. So if in your constructor you have any logic to validate your object, it's not being called. Because serialization and deserialization in this matter, they trust and they act upon, how do you call it? Reflection. Reflectively, they put the values back into the object because you want it in the same state. So with bypassing the constructor, they will just inject the values as they are. But you saw that I could already change these values. So, okay, take that, hold that thought. Say it is not the object that I actually expect. It's not a value object, it's something else that's in that input stream. What is the exception I get? Who was a Java developer again? It is a class cast exception. Because you're having something in memory, and then you try to cast it. But that doesn't work. But think about it. It is already in memory. Uh-oh. Again, hold that thought as well. Because now we need to go to what we call gadgets. Who understands this reference? Yeah, I see some nods like, yeah, Inspector Gadget. We're not going to talk about flying people with helicopters. We're also not talking about smartphones or smart systems. No, we're talking about gadgets. So what is a gadget? A gadget is an object that if I make an instance of an object, it automatically has a side effect. And some side effects are good. Some side effects can be really, really, really bad. So, just for, again, the sake of argument, I created such a gadget. And I created the gadget in the same way as you normally do with serializable objects. This gadget object has one field, and that field is a runnable, which is a command. Well, normally, if I create a command, I do that using the constructor. But I know that with deserialization, we do not use the constructor. We bypass the constructor. But what can you do? You can override this private final void read object. Yes, it is true that you can override a private final void because of reflection. And in that private final void read object, I basically read the object in a default way, and as a side effect, I execute the command that was my field. Well, hopefully nobody creates such a gadget in their own class path. Hopefully not. But the thing is that if we look at how deserialization works, again, see that third line? In.readObject. And what kind of exception did we get? A class cast exception. But the thing was already in memory. So guess what happened? It was already executed. I will show you. So I have a gadget here. It is exactly the gadget that I showed you in the previous slide. It has a runnable command, and as part of that read object, it runs the thing. All right? So what I'm doing now, I'm having basically two methods, serialize object and deserialize object, and these contain exactly the four lines that I showed you on the slide. So let's serialize this object to gadget.ser, and as a side effect, I will say new command, and I give it the word or the value env, and basically that is a terminal command on a Linux machine or a BSD machine to show you my environment variables. So if I execute this, it will be fine, right? It just run it. Okay, it runs. So we have that gadget.ser file that is here. Let's now deserialize it. If I deserialize it, what you see is that I actually, let me enlarge this, that I actually have the class cast exception here, but because the thing was already in memory before we tried to cast it, as a side effect, it already gave me my environment variables. This means that, okay, oh, wait. Is my GitHub token in there? No, I'm kidding, it's not. But what the thing is, that if such a gadget exists in your class path, I can misuse that gadget to insert something else that you did not expect. Because it is already in memory, it already gets executed, and then you try to mold it into the right form. And then you get a class cast exception. That's horrible, because now I have an entrance to do arbitrary code execution on your machine. Because you, for some reason, accept serialized objects. This is great. So, people will say to me, Brian, this is all fun and stuff, but who on earth would create this object and put it in the class path? That person would be insane. You should fire that person, or at least shoot him in the knee. Once, because everybody deserves a second chance, right? Well, the thing is, it is not that one object. This is what we call a gadget chain of one. But it can be that if you use an object that contains another object, that contains another object, for instance, a list or a map or a collection that contains an arbitrary object that is something, that contains something that is something. And you know, with generics, it's quite easy to do that. In the end, I need one starter kickoff gadget that overrides that read object value. And in the end, I just chain a lot of objects into each other that hopefully in the end there is something that can actually spit out my arbitrary code execution. So you would probably say like, okay, But who overrides the object read value? That would never happen, right? Sure. Just go into the JDK and look at HashMap. Look at HashMap. Decompile it or download the source code and look, they override the read value. So that's already an instance gadget. Now you just have to find the other ones, connect them together, and kaboom. So yes, this is possible. But to find such a gadget chain, or to create such a gadget chain, isn't it hard? Sure. But can you imagine if you, well, let me ask you a different question. Who uses libraries and frameworks in their application? There are two people like no, because I'm a Node.js developer. No, I'm kidding. Everybody uses like things like Quarkus, Spring Boot, Micronaut, whatever you use, it doesn't matter. But you know that a Spring Boot starter is just an empty jar with another POM file in it that brings in a ton of other libraries and frameworks that depend on frameworks, that depend on libraries, like several layers deep. Can you imagine how many classes are there available on the class path? A lot. Just keep it to that, a lot. Like if you just count the amount of packages and say every package averagely has 10 classes, and that's not true, it's even more, but you can imagine how many classes are there on the class path. Combine that with your own classes and combine that with whatever is possible with your JDK. These classes all together are available to you, and now you just have to cherry pick and create such a gadget chain. Okay, but that is hard, that research, right? Sure, but there are tools for that. Because why so serial? Why so serial is a project on GitHub, and it is purely for educational purposes only. Yeah? Repeat after me. This is purely for educational purposes only. Yeah? Don't use it to hack somebody. If we take a look at why so serial, it's a GitHub repository that is there available to you. And it basically creates the payloads of known gadget change for you. Isn't that sweet? If we look at the README file, they found a bunch of them. And this is just a subset. So these gadget chains exist. These gadget chains are identified. These gadget chains are published. And somebody took an effort to actually create a generator for me. Isn't that sweet? But it can be just a single library, in this case, Commons Collection 3.1, which has a full gadget chain from a kickoff to a sync. But it can also be a combination of libraries. This one partially said JSON lib, Spring AOP, and a bunch of other stuff. So it can be a combination of both. It's just a matter of time for people to find it. But hey, there are not a lot of people that do not have a life and just try to create gadget change. Trust me. All right, I'm going to show you this by using this one, the Commons Collection 5. Well, this is the 5th problem they found in this Commons Collections library. One tip, don't use Commons Collections 3.1. Just saying. Anyway, so what I'm going to do is I'm going to use this. I downloaded the binary from YSOSerial already. But let's go into the class first. Because if we look at how this works, and I go into the source file, I will zoom in a second. Hopefully my internet works. Yes, it does. Nice. Let's go into payloads, Commons Collections 5.java. All right. If you look here, they use things like invoker transformers that are available in that library to change certain things. And if you look at this closely, they call the runtime class. With the invoker transformer, they get a method. They get the method getRuntime on the runtime class. And they basically then call execute. And that's all part of a, if I'm not mistaken, a lazy list or lazy map. So with only that library as a dependency, I already have for free a gadget chain, and this thing can generate things for me. So let me just demo that for a second, that it's actually true, and I'm not just making things up, because that's what somebody sometimes says to me. I think it is. sample 3. Yes, it is this one. So, what I'm doing here, I am using the lazy map, so I'm absolutely sure that it's in memory. So I know that the whole jar of comments collection is in memory. And then what I'm doing here is I am deserializing a file called payload.ser. Well, we do not have payload.ser yet, but let's create that one. Yes, I made a little cheat sheet for myself. So let's get the terminal up. Oh, it's already here. So let's not call it hello people.file, but hello, the DevBcn.file. Doesn't matter. So that is the command I give to comments collection 5, and I put it into payload.ser, as I say here, by using this YSO-serial compiled jar. Cool, let's do this. So let's see if it's created. We have payload.ser just created, and let's go back to my file. Okay. So if I run this, oh, this is example 3, so I need to run this one. You will see again that I will get a class cast exception, right? But we know from back with that simple thing that I created for you that the crap already happened. We're already screwed. So looking into that, you will see now that I created a file, hello DevBcn, by just deserializing a payload. And if I can create a file, I can create a file containing content. If I'm able to do that, I'm able to do arbitrary code execution, come back tomorrow, and actually execute that script that I just created for you. Good luck in your postmortem finding out what the heck happened. This is a problem. And guess what? These things exist in your applications as well. So, getting back to, where is my presentation? Probably here. I borrowed this slide from Ian Haken. And Ian Haken is a researcher at Netflix. And back in 2018, at Black Hat USA, a security conference, he held a talk about problems with deserialization gadgets. What they did at Netflix, they created a scanner, an analyzer for their own tooling. And in that tooling, they tried to figure out if they had gadget chains in their application. This was the result for, at that point, their web app 2. And I'm not sure if it still exists, and I honestly don't care. But what you see here is that they found a full gadget chain from start to end using basically 6 libraries and the libraries available in the Java runtime. So combining things from ThoughtWorks, comments configuration, some closure stuff, AspectJ, and so forth, specific classes tied together, they were able to create such a gadget chain and do arbitrary code executions. So chances are that they are available in your application as well. But again, you will say, fine. When does this actually happen? Funny question. Where were you at December 10th, 2021? I was actually about to go on vacation. It was on a Friday, a very nice Friday, until I opened my email box and saw on the Java Champions email list, saw emails from Martijn Verburg and Bruno Borges, both from Microsoft, that there was a so-called issue with a library that logs in Minecraft. I'm like, sure, Minecraft, whatever. I don't play Minecraft. I don't even have kids. It turns out that that was the start of Log4j when it was disclosed. Who felt the pain of Log4j or Log4Shell? In the end, this was a deserialization problem. Log4Shell, as you know, was a library that was there in a lot of application transitively. We looked at the stuff that we have at Sneak, and we analyzed stuff for our customers, and we saw that almost 60% at that point, 60% of our customers did have that library included, but as a transitive dependency, and they didn't even know that they had it until we pushed it to them. At that point, over 17,000 libraries were vulnerable because they have it as a transitive dependency, and in the first 72 hours, over 800,000 automated attacks were done. this was a big thing. Who knows how this log4shell schedule works? Well, I'll give you a brief overview with my childish drawing over here. I know it's childish, but it explains the stuff. Well, for instance, we have an application here. Here, my app. Again, naming is hard. Say I know something is logged using log4j, and that log4j version, that vulnerable version. If I'm absolutely sure something is logged, I can misuse that to make a log string like this, with a percentage sign and calling a JNDI lookup. Well, what the JNDI lookup does is that it uses JNDI within Java to do a lookup to an object. And fun fact, it doesn't only look at the object, it retrieves the object. Hey, where did we heard that before? And for some reason, this was allowed to use the LDAP protocol. Well, guess what? If I just set up an LDAP server, like here, on my evil.com website that I own, I can return a reference. And if that reference contains a pre-compiled file that I serve to somebody, for instance, via HTTP, it will get retrieved and your evil.class is in your application. Oh yeah. When will this happen? When somebody logs something? For instance, if you try to log in and use the wrong password, you probably have a log line in it, user, and then the username, fill the temp number 1 or fill the temp number 2 or something like that. Because you see it's a real username or something like that. So then it's logged. That's a pretty plausible situation. Well, what if that evil class looked like this? It's not the read object value, but something else. It's just an object factory. And the only thing you need to do if you want to include an object factory, you have to override the get object instance. Well, guess what I did? I created a side effect in that get object instance by doing this. And basically, it says, open the calculator. Ta-da! Well, obviously, I can demo this. As in, I have my application running here. It's a Spring Boot application, and it runs on a somewhat older version of Java. I'm not sure if I can find it, but it's Java 8 build 111. Never mind. In the second try, can I find it? Yes, Java version 100, build 111. I come back to that later, why this is important. In my second tab, I run the LDAP server as described and the HTTP server to serve that evil.class. So what I can do here is I can, if I do just try to log in and I say Brian and I give it a fake password, what I see down here is that my username, it's on 2 lines, I'm sorry, but you see that the username is logged. Yeah, you got me, right? You understand. So I can misuse this. First of all, I need to make sure that my one password is off because it will start to scream at me. Yes, cool. So all right, so what I can do now is I can use this phrase as my username, connect to my LDAP server that I just created on the other side on still my local host, and give it a fake password. And as a result, you will see that the calculator starts. And this is all fun and games if you want to calculate things, but who cares, right? Well, it can be, again, if I can open a calculator, I can do other stuff. I'm allowed to start up other things. I can execute code within the boundaries of the user that runs that application. So, okay, fun fact, question. What is the default user if you run your application in a Docker container? Root. If you don't set a specific user, it's root. Hey, that's fun. Just put the whole JDK, Maven, and all your source code in that container, build it, run it. It runs, right? Now I can get in, stop your application, rewrite it, and I have the JDK and Maven available to just compile everything and start up my Bitcoin miner in your Docker container because I'm root. Well, the thing was, and why I said Java 1.8 build 111, that was on purpose, because one of the things is that we found out that we thought that it was only in lower versions of Java or lower builds of Java. In newer builds of Java, it shouldn't happen that way, because in older builds of Java, the flag trust URL code base, which basically means whatever is on the other side I trust it. That was set to true. After, for Java 8, for instance, build 191, that was set by default to false. And then we're again, fine, we're done, right? It doesn't happen anymore. Except if that class was available on your class path. So we're coming back to the point that if I just change my application a tiny, tiny little bit, and let's see if I have it open. Not here. But say I'm using that LDAP server, and I'm using that same code from YSOSerial to create that same gadget chain from Commons Collections 3.1, and because I have Commons Collections 3.1 in this application, I can misuse that by just copy-pasting it and sending it as deserialized stuff and use log4shell, log4j as a vehicle to execute that, that payload. So let me, I have time left. This is interesting. So exploits, server. So this is my server, and I will, so instead of going to evil.class, what I'm going to do now is I am going to leverage something else. I'm going to leverage the gadget chain that, I think it's in the bottom. Yes. Comments, use LDAP. Oh, and the payload I'm going to send is this. Who knows what this does? This is what we called a reverse shell attack. Because I'm on your machine, I'm acting as you, and now I'm deliberately from your machine, I'm creating a connection to my machine. Because you initiated it, it's all fine. I just have to listen to port 9001. But I am using the Commons Collections, send Commons Collections, here. Again, the invoker transformers that we've just seen. Runtime, get method, and execute that method. And I sent it as Java serialized data. So I'm now using the Java serialization stuff, which is natively there, and use log4shell combined to do a reverse shell attack. Okay, fine. First thing I have to do over here is start this up in a Docker container, because that Docker container contains a newer version or a newer build. Oh, Docker could not down. I'm an idiot. Docker compose up. So I'm starting up the same application, but now in my Docker container. I still have my LDAP server running, which is fine. Or fascinating, some people might say. And instead of connecting to my local host, I now connect to my Docker container. So I connect to my Docker container to that same part, but now I'm using that Commons collection because I mounted that to that /commons stuff. Oh yeah. I need to listen to port 9001, netcat minus LVP 9001. Okay, listening. Let's put in a fake password. And now I connect it from my remote machine to my local machine. And this could be any machine on the internet, running on Heroku, AWS, Google. And guess what? I'm in. I have a shell. Who am I? Who am I? I'm root. So the thing is, even if you think I don't accept serialized payloads, if you have it and you had log4shell in it, you were vulnerable as well. So yes, log4shell was an enabler to use serialized payloads for arbitrary code executions. Which means if you didn't update, please do. All right, enough of this. So what about stuff in JDK 16 and 17, right? We have records. And if you look at Oracle, they say records will solve serialization. But does it? Say I create a record like this, a 2 value, and that 2 value has 2 values. And I overwrote the constructor. Normally you don't do this, but I did it for the side effect of printing. And it shows you something. So say I'm doing the same thing. I create that to value. Then I serialize that to value. You see the same 5 lines as we had before. But before serializing it, I say, hey, dash, 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 serialize. Then I deserialize it with an output, with a print. Let's look at the output, what it gave me. It said, creating a to value via the constructor. That's true, because that's literally the first line. Created a to value. Then it serialized, then it deserialized, but when deserializing, it said creating a to value via constructor. Which proves that with records, you do not bypass the constructor anymore. You actually use the constructor because it's an immutable thing. You use the constructor to recreate a deserialized payload. So the very first problem I showed you, that if we have a payload, we could change the payload and that would be effectively injected even though it was a side effect. That's not going to happen. If you have something like logic to see if your value is actually something that could happen, if you only use records, you will be fine. The only problem is it doesn't solve the rest of your problems, because we're still using the in.read object. So unless everything is a record, it's still an issue. So records help you already a little, but not a lot. Because that in.read object is still the same way of actually deserializing a payload, giving you the class cast exception, but the harm is already done. So what can we do? That's the most important part. What can we do? First of all, if you need to implement serializable because of, I don't know, inheritance from a model, you can either give it an exception. Yes, it's better to have an exception than to have an arbitrary code execution. That's one thing. But it might be that you are depending on serialization. You actually are using serialization. Well, what we need to do is we need to inspect that input stream before we cast it, before we actually put it into memory or we do something with it. One thing you can do is use Apache Commons I/O. Apache Commons I/O uses the validated object input stream, and you can create an acceptance list with only the classes that you accept. If it's something else, it will not be loaded into memory because it looks at signatures and something like that to make sure that no other things will get into memory to get the attempt to get deserialized. But Java itself also has things. JEP 290 was released in Java 9. Who of you is still on Java 8? This is a great thing you should update. Yes, I know, you've heard this for like 14 years now, but there's a reason. Anyway, in JEP 290, they created filtering. So you could create a filter that says, hey, I only accept the value object and nothing else, or I only declined a certain object, or I look at a specific array and it can only go into a certain depth. All these things you can carry with these filters. The only way it wasn't foolproof. So there was JEP 415. The thing with JEP 290 was you could set this filter either as a JVM parameter or in code on a global level and on a specific input filter, of input stream level. The thing was, if you have one at the global level and you put another one at the stream level, it would override the global one, which is not great, because even though you set something, you don't know if a library that you're using is overriding it. Because do you inspect all the code that you pull in via Maven or Gradle? Some people are like, yes, sure. Yeah, I bet you. Anyway, with Java 17, I'm sorry, JEP 415 was released, and you could set a serial filter factor. And in that factory, you could give it a lambda or a function how to deal with two different filters, how to deal with that. And in this case, I say, hey, just merge it. So just to show you, I have 12 minutes left. This is the wrong one. I think it is. I don't need this one. I don't need this one. I do need this one. So what I'm doing in this one, I'm creating a to value. I'm doing all sorts of stuff. And I'm setting this object filter over here, just like I showed you in the slides. Then, in my deserialization, my save deserialization, I set a second filter. So if I run this one, you will see that now as an output, oh, this one, you will see I have the merge of two predicates. So both filters are still in play. If I remove that lambda function, if I remove this one, and I run it again, you will see that only one predicate is in play. So that means that if your library is setting these things, they override your global filter you already set, so you're still not sure you're safe. So if you're using filtering and if you're depending on serialization, update your Java 17 and use JEP 415 or the Commons IO library. All right. If you want to know more, I created a to-do, how to do this, blog post kind of thing, and how you actually could do that yourself with working examples. Yeah, sure, but we're not using serialization. We are using JSON. Who is in that game? Who's using JSON with Jackson? Yeah, sure. Jackson is shipped to you by Spring Boot, right? It's the most used framework to what we now call marshalling text to an object or object to a text. Guess what? It's just serializing and deserializing. One thing you can do with JSON, and luckily JSON does not set this by default, but you can enable default typing. And the name is confusing because, again, naming is hard. But who knows what default typing is in JSON? Who uses default typing in JSON? Thank you, because don't do this. Default typing is the thing that enables you to use inheritance. Say, for instance, I want to deserialize a JSON object that can be either a cat or a dog. But I'm not sure if it's a cat or a dog. What I know, it's an animal. So I can deserialize to animal. All fine, right? Seems legit. But I can also take this to the extreme. Say I have an object person, and instead of the name being a string, I could be an object. And again, who would do that? For instance, look at the objects in EH cache. They all contain objects because they're just wrappers. And there are a lot of these things in your class path available. But say I have the class person. I can deserialize it or unmarshal it using JSON, and I can unmarshal the string below, like age 37. I wish I was still 37 with my name, and that would be fine. But I also have a gadget in my class path, so I can also do this. Instead of having a name, calling that specific object or that object chain, and actually give it a parameter, and that will be deserialized as well, and you're in the same boat as we saw before. So, the thing is, do not enable default typing in JSON. By default, this is off, so let it stay off. Do your code reviews, and make sure that it's not there. Because you might think, like, how many of these issues are there? Well, I just did a research. These are from our vulnerability database, and every other week there is a vulnerability with deserialization in JSON because they found another object that can do this, but what they did, they put it, in this case, they put it in the block list. So they're actively blocking these gadgets to make sure that doesn't happen, but it's up to you to update to newer versions. So, one thing, do not enable default typing and update your libraries, in this case, JSON, to the newest version. With the amount of time, I'm not doing YAML because everybody likes YAML anyway. But who is still using XML? Yes, you're using XML. Great, this is great. Well, XML has an issue too. And it is not for arbitrary code execution, but XML, again, is a format to serialize and deserialize things. Let me spin up a new demo. Because this one does not work. Let me kill this one. And this one. Stopping superheroes, it's all fine, stop it. Terminate. All right. Hopefully this works, because the demo gods are not always with me. Looks like it works. Cool. So, localhost 8081. Okay, I have an application that is a coffee shop. I can buy coffees and beers, and I can log in and register. Well, for instance, I can log in with a username called user and password. You guessed it, user. This is all fine in games, but one of the things we have, no, don't. Yes, I know I need to change my, I have some orders. And what I can do, I can export this order to XML. So let's do this. Let's look at the XML file somewhere over here. And let's open this with Visual Studio Code. So it's not a big deal. It's just basically my order date, the order line, the quantity. No, I don't want to update. And something, right? Nothing special. Normal way how you would print something like this in XML. Cool. But what we can do as well is we can import XML like this. And this one is a fun XML. It's the same markup, but a little bit different. So you see, still the same values, or at least the same scheme. But you see this one, right? One of the things we can do in XML is we can use doc types. And we can use doc types to include external entities. And that's a feature in XML. Guess what? This is a feature that is by default enabled in every XML marshaller that is there in the JDK, standardly shipped with you. What does it do? But normally you would do it to load DTO or DTDs to actually validate your XML files, which is great. But you can also use it to go to other paths or other files. And what I did here, I went to my @c passwd, and I bound it to the variable XXE, which stands for external XML external entity injection. Instead of the product name, I am now referencing to this XXE. All right, let's do this. So let's import, choose the file. Let's go to my workshop. And let's load this XML example. If I submit, you will see that over here, instead of the whatever it should be, I am now able to basically include data that is not mine, that is not should not be available in the sandbox of your system, but is somewhere else on your machine. And yes, it depends on if your XML or if your the user that you're using does have these privileges. But we just saw how that works in a Docker file. By default, everybody runs as root, or hopefully not everybody. But the thing is, this is a feature, and by default, you have to set that feature to untrue. You have to set that feature to disable external entities to be safe. This also means that if you're not including XMLs from an end customer, like a user in the UI, which normally you probably won't do, but you might include XML streams from a business-to-business coupling from another service. The thing is, if I cannot hack your system, but I want to disclose information on your system, I just go to the other guy. Make sure that their XML is having some weird tweaks in it, and I can use that to chain that into my application and actually disclose this information and put it somewhere that is to my convenience. The thing is, this is not as bad as arbitrary code execution, but by default, XML files are also in trouble. I can do this something similar with YAML files, but for the sake of time, with only 2 minutes left, I will not. If you want to see that, I'm all around, and I'm happy to show that demo. Snake YAML, which is still the 1.x version that is shipped to you with Spring Boot, is vulnerable to get-to-chain exploits, and therefore arbitrary code execution. Okay, let's wrap this one up. So, a few things we need to be sure of. First of all, do not deserialize input from unknown sources. Obviously, we don't do that. Or do we? Like, we consume XML streams, or maybe YAML files from somebody else, or JSON input. But if you don't have to, please don't do it. Specifically not the deserialized input that is to native Java. Prevent Java custom serialization as much as possible in general, because in most cases you don't need it. You still don't know if your libraries aren't using it, but if you don't use it, it's already less intimidating. Use filters if you still need to do this. If you need to include serialization, use these filters like in JEP 290 or 4015 or the Apache Commons IO library to help you out and to inspect that input stream. Be aware of how your JSON, XML, and YAML marshals work, and be aware of things like defaults. Make sure that the defaults, like luckily in JSON, the defaults are okay, but in other, they are not, like in the XML parcelers. And last but not least, update your insecure libraries. If I would have gone, and I have 21 seconds left to do this. For instance, if I would go to my serialization application example that I did for the first few things, and I would scan my library, either locally or on my GitHub repository, it will say like, hey, you've got Commons Collections 3.1, and you should upgrade to 3.2.2. That would get rid of that gadget chain already. Of course, it's impossible to do that for all over the place, but if there are libraries that are heavily armed with these kind of situations, you can prevent that by scanning throughout your development lifecycle. All right. That's basically it. I want to thank you for your attention. I hope this was useful, and enjoy the rest of the conference.